Well, hello YouTube world. Welcome back to the channel and welcome back to the lighter side of RC. We have an interesting test today. We are testing the high amperage capacity of the SolderStick connectors. This is going to be a great video. We are going to test it with a high current EDF unit and see if these things survive. This is one of those tests that I wanted to do since we did our testing video on these units themselves. There is a link down below to the SolderStick original test video that has some pretty cool results. Check it out at the end of this video. It's in the video description down below. So hang tight and we will check how these connectors work in a high amperage, high draw situation. All right guys, first things first, these connectors performed awesome under normal wiring circumstances, not necessarily high amperage draw situations. They held together very well. If you want to check that out again, check that video. I was very impressed with how those connectors worked in that situation. So one of the things that was brought up was how do these connectors perform in a high amperage, high draw scenario? And that's what we want to test out in this video. So this video is not sponsored by eFlight or Horizon Hobby or anything like that. This just happens to be a unit that I've taken out of one of my EDF planes that is no longer in commission. The equipment we'll be using during this test consists of a 100 amp eFlight ESC, and we will be powering that ESC with a 5000 milliamp 60C Gens Ace batteries. These are the batteries that I originally used with this controller. Our motor is an EDF unit, is also an eFlight unit, and there's the information on the motor. And this is I think a 90 millimeter unit, and works good when it was in the plane. No issues with it at all. So why are we doing this test? Well, generally, with an EDF setup, the wires going from the battery to the control unit or the ESC and the wires going from the ESC to the EDF unit, the electric ducted fan, generally get hot. Now these solder stick connectors, they are a low temperature solder connector, so what better way to test it than put it in a high amp, high temperature, high draw situation, and we'll find out if these things survive. What we're going to do is we are going to do an initial run on this setup without adjusting the wires at all, and we're going to have some of the consistent settings followed throughout both tests. So test number one, we're going to have the unit like it sits right now. We're probably going to run it at full throttle for probably a 3 to 4 minute period, and we're going to measure temperature at the wires, at the battery connector, at the ESC, and also at the wires going from the ESC to the motor, and we'll measure the motor. So we'll get temperatures across all of the different components. Then what we're going to do is we're going to add a solder stick connector in between the ESC and the battery plug, and we're also going to add a solder stick connector on this end here, and that's going to be a survival test to see if they actually hold up. So worst case scenario, the solder stick connectors, the solder inside melts and the connector easily just pulls apart. Best case scenario, it survives and nothing happens. So it's going to be interesting to see exactly what happens with these units. So what we're going to be using to mount our EDF on is our standard turbine unit that we use to test turbines. So we can clamp this all in, we can put the EDF here, and what we'll do is we'll have the ESC here, and we'll measure the temperature of all those components as they lay out here. Now this is really kind of a worst case scenario, because what often happens in an aircraft is your electronic control unit will be installed so it generally gets ventilation over top of it or through it or around it somehow. Now worst case scenario is you have poor ventilation around that unit and it doesn't get any cooling, and that's kind of what we're going to have simulated in this test. All right, so we've got two batteries that we're going to use here. We've got a battery number 2 marked, battery number 3 marked. Battery number 1 is just going to be to initialize everything and make sure that we have everything set up properly. Now, just to prove it, both batteries are fully charged. It's a 6-cell battery. Each cell is at 4.2 volts. This one is just finishing charging, so you can see there we're almost all at 4.2. It's just balancing out the cells before it's done. Okay, so we've got everything set up here. We've got our test battery, which is battery number 1. We've talked about that. That is all set up to the EDF unit. Now, one thing that's going to be interesting, this is not really part of the test, but we'll be able to see how much thrust output this EDF unit gives us. And just to show and prove that this works, our throttle stick's right there. There we go. So we're just waiting for our batteries to charge and we will do our first test. So the first part of this test is basically to get a baseline on what our temperatures are going to be. So we're going to run this for, I think, probably 3 minutes. That's my goal. I'm going to set a timer. We're going to run it for 3 minutes. We're going to measure our temperatures on all the different areas, and that'll allow us to have a baseline. And part of the reason for that baseline is when we add the solder stick connectors into the system, we want to make sure that it's not increasing the temperature, increasing the resistance, stuff like that. So that's the reason for the baseline. Okay, so just so you can confirm our baseline temperatures, we've got our new battery, which is our freshly charged battery, which is battery number 3. We've got our infrared temperature sensor, and our battery is sitting at 70 to 75 degrees. Wiring, all the same. ESC, 75-ish degrees, 79, because we've blipped it on a little bit. Wiring past the ESC, we are sitting at 75, and motor is sitting at 70 to 75. All right, we've got our protection on, our eye protection, our ear protection. I'm probably talking really loud. Let's run this thing. Initially thinking 3 minutes, we'll see how the battery does. At full throttle, it may not go that well. So anyways, let's turn this thing on. Woo! All right, guys, so let's check our temperatures here. We won't worry about stopping the stopwatch. So battery, we are a little bit all over the place, but we're like 100 to 120 degrees. Connectors and like wires, they're warm. Connector isn't bad at all. Wiring is warm to the touch. 75, 76 degrees. The ESC, this is obviously going to be the hottest thing. So we're like scanning the whole thing, and we're like 150-ish at the hottest section, 170. So the ESC got pretty hot. The wiring right after the ESC is in the 140 to 160 range. So when I actually touch this, definitely warm. Obviously the wiring on the inside is going to be a lot warmer or a lot hotter. So what we're going to do now that we've got a baseline of temperatures is we are going to let everything cool down. We're going to install our solder stick connectors, and we're going to do it one in between the battery connector and the ESC. We're going to go right at the halfway point, and then we're going to do one on the ESC to motor connection. So we'll do it just after the ESC, and we'll see how it survives. All right, so we've moved our whole system over here to the bench, and we're going to install our connectors now. Now, one thing I've found with the connectors is you always generally want to go up in size, sort of. So in this case, our main wire going from the battery plug to the ESC is 10 gauge wire. So if you look at the legend on the box here, yellow is for 12 to 10 gauge wire. So we're going to put a yellow connector here, and we'll probably do, this is 12 gauge as well too, so we'll do a yellow connector here as well. Now I've actually never used the yellows, but on a wire a little bit smaller, so like on a 14 gauge wire, you can use the yellows, but the blues are good. So anyways, don't, I guess what I'm saying is if this blue fits over the wire, doesn't mean you should use it. Look at the legend on the box and go by that. Now this is a great time, guys, to bring up SolderStick. Now SolderStick is a channel sponsor, and I appreciate everything they do for the channel. Thank you, SolderStick, for that. Now they are generous enough to give you guys a discount code for any purchases you make. All the information is down below in the video description. It's also in the description, the first comment of the video as well too. Now if you use the discount code RC20 when you check out at your SolderStick purchase, you'll get 20% off your SolderStick order. And I'll tell you, these things are awesome. Hopefully it survives through this test, because I've never tested them like this. Okay, so let's review how to do these connectors. So we've snipped the wire, slid a connector over top, pushed our wires together, and we're going to put our connector over the exposed wires. Now, there's no rhyme or reason as to why for this test I did the red wire over the black wire. I'm not sure it really matters. Temperature-wise, they were both warm. So now we get the little piece of solder kind of centered over top of the wire. Now for smaller wires, I like to use a lighter, but for this guy, we're going to use a heat gun just because it's a big, fairly large piece of wire. So what I'll also do is I'm going to get the ends melted first. So I just focus my heat kind of closer to the ends. And then now I'll start focusing the heat on the middle. And the solder's starting to flow. Okay, so that connector's done. We've got a nice melt going on the edge pieces. So we're gonna leave that alone. and we're going to move everything over and focus on our connector between the ESC and the motor. So we'll just pick one. Again, doesn't really matter, and we will splice this guy. So we're just going to go right in the middle, expose a little bit of our wire. Now this wire is 12 gauge wire. The other battery wire is 10 gauge wire. So we're still going to use the large connector, the yellow one. Okay, we've got that positioned over the wire. So let's heat it up. Okay, and the solder's starting to flow now. Now, this heat gun, it works. Not ideal. SolderStick, I think on their website, I've heard a few people talk about it and give it rave reviews. They've got a little soldering iron on there with, or a heat gun on there with a little bend on it, and that actually flows the heat all the way around the connector. I don't have one yet, but I think that's a very cool purchase if you decide to get one of these kits. Okay, so we've got our connector number 1 done up, connector number 2 done up. We're just gonna let that one cool off a little bit, and then we're going to get this unit reinstalled on our test stand, and we will perform the exact same test and see what happens. All right guys, we got everything set up and ready to go. I'm going to keep you a little bit closer this time, and we're going to have a continual look at all the different parts of the system, and so the entire 3 minutes I'll have you in my hand rather than having you stand over top. And we'll be monitoring the temperature and taking a close-up of everything. Of course, we got our safety gear on as well. All right, so we are gonna go, we're gonna start the timer, and at the 10-second mark, we are going to start our EDF unit. So we'll go to 3 minutes and 10 seconds. And go. Okay, so first thing we want to look at is all the temperatures. So we are, I guess, sort of similar to where we were before, because we were floating, I think, 140 to 160. Yeah, we got a 155 there, 145. So yeah, so temperature-wise, we're the same. Now, connector-wise, no issues at all. Both of those connectors are perfect. Now, the wires are warm, just like they were before. The connector is very warm. The battery is warm as well. I mean, I'm assuming we're pretty much the same temperature, 120, 110, yeah, all over the place. So, honestly, passed with flying colors. Good job, SolderStick. Well, I would definitely say that the SolderStick connectors get a passing grade in all circumstances. These things performed awesome. Honestly, much better than I expected. I wasn't sure how they would perform during this high amp draw scenario, and they did. Now, for you guys that actually watched to this part of the video, we are going to do a giveaway in this video as well. So we've got 2 of the 50-piece SolderStick kits here, and we're going to do a giveaway using the comments down below. So the first thing with the giveaway is you need to be, number 1, a channel subscriber. So if you're not a subscriber, hit that subscribe button down below. Got to give the video a thumbs up. The other thing you need to do is make a comment in the comments down below using the word solder. So using the word solder, S-O-L-D-E-R. Doesn't matter how you use that word, be creative. I enjoy reading all of the comments. It's tons of fun and usually gets me smiling and gives me a big laugh. So definitely not an issue using it in this application. As I mentioned, I was very impressed how that motor is hot. Worked out awesome, so no issues with that at all. Thank you for watching the video. Again, don't forget about the discount code at SolderStick. All the information is down below in the first comment in the video or the video description. Use the code RC20 and you can get 20% off your SolderStick order. Thanks guys for watching. If you have any questions or comments, list them down below. Use the word solder and you're entered to win a 50-piece SolderStick kit. Thanks for watching, guys, and we'll see ya in the next video.